Hello everyone, today in this video we'll be discussing the third module of AI/ML, and in this module we have two topics. Okay, how many topics are there? Two topics. If you listen carefully to me and you bear with me till the end of this video, you'll be able to capture all the things in a butter smooth manner. Okay, so there are some concepts which require to be taught first, then the next concept will be taught first. Okay, but in the syllabus it's given in a different order, like the basics are taught first, then examples are given, and then the other topics are there. Okay, but I follow a different approach. I'll be first directly going to the example parts, and I'll be making your foundation in that thing strong. Those questions are directly from the question papers, previous year question papers, so I'll be telling you how to solve them. If you get to know how to solve the examples, like the main heart of this module, like the first part of the module, there is a concept called as decision tree. Okay, so there are some examples which are given in the previous year question papers. It has been asked, so it's a very short question. If you know that, you will be easily able to know the basic concept behind that as well, right? Also some of the other things like advantages, disadvantages, how is it effective as compared to others, what are its applications, all those things will be covered. Okay, so first let's directly go to the example part. Okay, so in the next part of the video, means in the another video I'll make for the second part, which is about artificial neural networks. Okay, so in this part I'll be just discussing the decision trees and its aspects as well as examples. So there are totally 11 questions, and the important ones are just 4 or 5 questions. Okay, but the examples parts I have taken many questions to make your basics stronger, because if you just listen one question in decision tree, it will not be sufficient. Okay, you won't get the concepts. So I have taken 3 or 4 examples in that. So totally topics are just 4 or 5, but I separated each topic like short questions. Okay, so before starting, if you like this video, hit the like button, and don't forget to subscribe to my channel. Your support helps me make more videos like this. If I've got any doubt, you can ping me on Instagram. Okay, so let's get started. By the first topic, you need to know what is decision tree learning. Okay, they'll if they ask you about the definition of decision tree learning, at that time what you have to write is decision tree means what? There will be a tree. You know how the tree is, right? There will be a root, there will be some nodes. Okay, and these are the leaves part. Okay, this is the end, this is leaf, and this is nodes, and this is what? The nodes, normal nodes. Okay, and what is decision tree learning? You'll be having a concept, like for example, you are hungry and what you want to eat, you want to go to KFC or McDonald's. So that is one choice you have got. If you go to KFC, you want burger or you want french fries. In that, another choice will be there, which burger you want, chicken or beef burger. So like that, it will be many choices will be coming, and it will be going. That is called as decision tree. So that's what we'll be learning here. Decision tree is a method for approximating discrete valued target. Discrete value means they'll be having specific values like yes or no, or some specific instances, not like continuous values like more than or less than. They'll be having discrete valued functions in which the learned function represented by a decision tree. Okay, this is the definition what you have to write first if they ask you about decision tree learning. And there's an example here. What does decision tree do? See, an example is given here. Here's a root node called as outlook, and how is the outlook means how is the weather outside, sunny, overcast, or rain. Okay, so these three values are given. If it is sunny, if in that there is another specification like humidity. If it is high, then no. If it is normal, then yes. These are the values for playing tennis. A person wants to play tennis and he wants to decide in which circumstances will he be able to play. So according to his desires, if it is overcast, he will play for sure. If it is sunny and normal, then only he will play. If it is raining and weak, then only he will be able to play the tennis. Okay, it's raining and the wind is weak. So we'll be constructing this tree from the scratch. We'll be just given with a table, and we'll be seeing further how to move ahead with that. So this is the example and the definition you have to write if this question is asked. Then you have to move towards the next question, which is list and explain the appropriate problems for decision tree learning. Okay, so whatever the concepts are there in machine learning, there are some disadvantages to that as well. So let's see what are the disadvantages of decision tree learning. The first disadvantage is that the instances are represented by attribute value pairs. Okay, I don't know what is the disadvantage in that, but still just remember this for marks. Instances are described by a fixed set of attributes and their values. Okay, so there may be some disadvantage which is not written here, but you have to remember the attribute value pairs are there. That representation has some disadvantages. Okay, next is the target function has discrete output values. Discrete means yes or no. That is a disadvantage. Disjunctive means no connection. Disjunctive descriptions may be required. Connectionless descriptions may be required. That is a disadvantage. The training may contain error. The training may contain missing attribute values. These are the five problems, or the problems to the approaches in the decision tree learning. Okay. Next we have the basic decision tree algorithm. Okay, so this algorithm will make more sense to you after we will be discussing the example, and I will be coming back to this problem. Okay, after this the question is regarding the entropy and the information gain in the decision tree. Here also some formulas are there. I will be just directly discussing in the um, example. So in that I will be applying these formulas, and I'll be letting you know how it is. Okay, if you get to know that example easily, you will be able to write this definition also. So I'll be not be explaining this one, as well as here I'll be just going through after the example. Okay, the next question is the main question, which is from the question paper. Write and explain decision tree for the following. You have to listen carefully, even if it takes as much long as time it requires. As much time as it requires, let it take, but you have to understand this concept very well. Spend your time, it will be worth it. Okay, so here's a table in which how many rows are there? 14 rows are there. Okay, and let's have a look at the attributes. What are the attributes? Day, outlook, temperature, humidity, wind, and play tennis. So these are the attributes given to us, and if these attributes are there, the person will play tennis? No. If these attributes are there, will the person play tennis? No. If these attributes are there, the person will play tennis? Yes. Yes, yes, no. Like that, all 14 attributes are given to us with different values, and the values are, the target function is given to us whether the person will play tennis or not play tennis. Now our task is to construct what? A decision tree. In the question what they have asked, write and explain a decision tree for the following. Okay, so we are supposed to explain a decision tree for the following. How do you make a decision tree? Okay, have a look here. The day is given. Day is just like a numbering. Okay, it does not have any attribute values. Outlook, temperature, humidity, and wind. These four things are given to you. Okay, outlook, temperature, humidity, and wind. Now what we are supposed to do is we have to find out what is the values present in the first column. How many values are there? You tell me. Distinct values. Sunny is one value, overcast is one value, rain is one value. How many values are there? Three separate values are there in the first column. That's what we will be first writing. Attribute. What is the first attribute? That we will be writing outlook, and after that we will be writing how many values are there in outlook. There are three values in outlook, which is sunny, overcast, and rain. Okay, after you have written this much, then you have to find something called as entropy. How do you find entropy? That I will be telling you now. See here, when you observe this carefully, how many no and how many yes you can find here. Out of total 14 no and yes, how many no's are there, how many yes are there? Count and tell me how many no's are there, how many yes are there. If you count, you will get 14 in total, and the number of no's is 5, and the number of yes is 9. Okay, so you'll be representing like this. How many yes are there that you will represent first? How many no's are there that you will represent after that? Okay, then we are supposed to calculate the entropy. S means the whole data set. Okay, for the whole data set, what is the entropy? For that, the entropy is calculated as follows. Listen carefully. You have 9 yes here and 5 no here. Okay, so that's why I have written 9 and 5 there. Now to calculate entropy, what you will be doing is, first you have to write what is the probability of yes. There are 9 yes out of 14 instances, right? So you will be writing here minus 9 by 14. Log 2, again the same thing, 9 by 14. Minus 5 by 14 log 2 5 by 14. Just insert this in the calculator and find out. You will get the answer 0.94. Keep it as such. Okay, then the same thing you have to do for S sunny, S overcast, and S rain. In values, in the outlook values, how many are there? Sunny is there, overcast is there, and rain is there, isn't it? So for each of these we have to calculate separately. What is the entropy of sunny, what is the entropy of overcast, what is the entropy of rain. How do we do that? How many sunny are there? First you tell me that. Let's count how many sunny are there together. Okay, 1, 2, 3, 4, 5. 5 sunny are there, and how many no is there? How many yes is there? No, no, and no. 3 no's are there, and 2 yes are there. Okay, 2 yes are there, and 3 no's are there. Okay, so that's what we will be writing here. 2 yes are there and 3 no's are there. So I'll be writing there 2 plus and 3 minus, besides S sunny. After I have written that, what I have to calculate? Entropy, as we did previously. How will be entropy calculated? You have to tell me the probability of yes and probability of no. There are totally 2 yes out of 5 no. You'll be writing minus 2 by 5 log 2 2 by 5. The same thing goes with the no also. 3 no's are there, minus 3 by 5 log 2 3 by 5. Just insert this in calculator, you'll get an answer. Keep it as such. Next we have to find out the same thing for overcast. You just calculate how many no and yes are there for overcast and then write here and then calculate it. Okay, I'll tell you one trick. What you have to do is, if you get here like 4 and any of these two values, if you get 0, the answer will be 0. If you get both the same values, the answer will be 1. Just keep this in mind. So when you calculate for overcast and rain, you will get two answers here, isn't it? Now what your task is, you have to compare each of these. Okay, outlook is given here and some values we have got here. Now we have to apply a gain formula. This is called as entropy formula. Next you have to apply the gain formula. What is the gain formula? What you will be writing is gain S and outlook. S is the total data set we are considering. Inside that, which attribute we are considering? Outlook is the attribute which you are considering first, right? So S comma outlook you will be writing. Okay, so if it was not outlook, if it was humidity, what you will write? S comma humidity, right? Because if the attribute is humidity, here also we will be writing gain of S comma humidity, but since it's outlook, we are comparing the gain with respect to output, so we will be writing here outlook here. Entropy of S minus summation of SV by S entropy of SV. Now let's have a look at what is SV and what is S. SV is nothing but values. First time we'll take sunny, then we will take overcast, then we will take rain, and each entropy will be inserted here. The entropy of SV, which is sunny, overcast and rain, these three are calculated here itself, right? We just calculated these three values. These three values are the entropy of SV, which is sunny, overcast and rain, and entropy of S also we calculated the first part. Now you understood why we are doing this one. We will be inserting these values in this formula. Okay, when we insert this thing in the formula, entropy will be inserted as 0.94, which I have just written here, and this summation is written here, right? What is this summation? This is the same thing which I have taken it here, 5 by 14. This is SV by S. What is 5? 5 is nothing but, for sunny we will be taking 5. Why we are taking 5? Because the total values for sunny is 5, right? 2 plus 3. The total values for sunny is 5 only. In this whole data set, how many sunny values are there? 1, 2, 3, 4 and 5. So that's what we will be taking. How many total values are there? That we will be taking. Okay, what we will be taking? How many total values are there divided by all the values. How many all the values are there? 14. Inside that, how many sunny are there? 5. How many all the values are there? 14. Inside that, how many overcast values are there? 4. How many values are there? 14. How many rain are there? 5. So we'll be writing this 5 by 14, 5 by 14 and 4 by 14. After that we'll be multiplying with the corresponding entropies which we just found out. Okay, so when we do that and substitute each of these values and calculate an answer, we will get as 0.2464. okay, you can calculate and see the answer will be 0.2464. just keep it aside. What you will be doing is, above this one you will be writing 0.2464, not actually writing, in your mind you will be writing. Okay, so after that is done, you will be doing the same thing for temperature, humidity and wind. Now what you have to answer me some questions. Okay, what is my question is, in temperature how many values you can find out? Distinct values, you tell me how many you can find out. Is it 0, is it 1, is it 2, is it 3? Distinct values means what? There are different values. Okay, here I have hot, same. Mild is a different. I have two distinct values. Cool is different. I have three distinct values. Cool, mild, hot, mild. So all the values are same after that. So just I have found how many? Three distinct values I have found. So again, what I am supposed to do? I am supposed to write it as attribute. And which attribute I am currently considering? Temperature. I will be writing a temperature. Then I will be writing how many values the temperature has: hot, mild and cold. I will be calculating this one. This one is, since it's same, I will not be calculating again. I just am concerned with S of what was that? Hot, and S of mild, S of cool. I'll be taking how many positive and negative values are there for each of these, and then I'll be inserting them here in this formula, and then I'll be calculating. Since you're all experts in maths, I'll not be explaining you how to insert these values and calculate. I'll be just skipping through it. Finally, you'll be inserting then these values in the gain formula also, S comma temp, just as how we did for this one, right? S comma outlook we did, right? So we'll be getting here also S comma temp. We'll be just inserting entropy will be same 0.94, and here the values which is the how many values are there for hot, how many values are there for mild, how many values are there for cold. Each of these I'll be inserting. For example, for your satisfaction, I'll be telling V is first hot here. Okay, so I'm concerned with how many hot values are there in the table. In the table, if I calculate how many hot values are there, 1, 2, 3, and 4. So totally 4 hot values are there among 14 hot values. So what I will be writing there? Obviously I will be writing 4 by 14, isn't it? The same way it goes for mild. There are totally 6 mild values. For the cool, if I calculate, if it will be 4 cool values. So that ratios I will be writing, and these answers which I just calculated above in these formulas, that I will be substituting in the formula. When I do that, I will be getting one answer there. That what I will be doing, I will be keeping it aside. Okay, 0.0289. Where you have to write this answer on the top of this one, not in reality but in your what, imagination. Okay, you'll be writing the answers in top of these both. Same thing you'll do for this one also. Now answer me how many distinct values are there for humidity. The answer is 2, high and normal. So we'll be doing that only. S high, S normal, we'll be calculating. Wind also weak, strong, S weak, S strong. After you have done that, we are done. Okay, first step is over. We considered all the attributes and we just calculated the entropy values for each of these, and we wrote on top of this in our imagination. Now what we have to do is we have to select the best value. When there is a race happened between 100 people, just 4 people got selected. Then the final race will happen. Who is the best runner, right? We are always interested in who is the best person, right? So we'll be making them run with each other. These 4 answers which we got, that let me write down here. These are the 4 answers which we got. For the outlook we got one answer, for the temperature we got one answer, humidity and wind also we got one answer. Now from these answers we'll be selecting the highest value. Now who is our winner? Our winner is outlook. So what we'll be doing, we'll be giving the first priority to the outlook. By priority, what I mean is I'll be selecting that and keeping it at the top. Okay, because he is the topper, I'll be keeping him at the top. Now I'll be writing here outlook, and how many values are there positive and negative in outlook, that I'll be writing here. That already we calculated, right? Where was it calculated? Go back to when we considered outlook here. In outlook, how many values were there? Sunny, overcast and rain, right? And that was the total values. In that we got 9 positive and 5 negative values, right? See here, you got totally 9 positive and 5 negative values. So that's what I'll be writing about outlook. Outlook has got that title, so I'll be able to write this one here. Okay, outlook, and that values how it is differentiated: sunny, overcast and rain. So outlook's attributes are the main powers here. Okay, he will be able to exercise his powers on the other data sets. Now the differentiation will happen on based on sunny, overcast and rain. So what we will be seeing is we'll be writing a sunny, and we'll be seeing how many values are there for sunny, how many values are there for overcast, and how many values are there for rain. Now if you go back for sunny, overcast and rain, okay, in sunny, overcast and rain, you tell me how many values are there. 5 values are here, 4 values are here and 5 values are here. The same we will copy paste in that part here. We'll be just copy pasting it here. Okay, so when we do that, we'll be also mentioning which row numbers were for these values, 2 positive and 3 negative. We'll see the table and we'll write which row numbers were for each of these. And after we have written that one, what we'll be doing is we'll be calculating if it is yes or no. Means, are we sure that these values are correct and these values are correct? What I mean by correct is I'm not able to actually explain that in words. If I tell you here, what I'm trying to do is I'll be just seeing here, see what all the things I got here. Well, we reached till this point, right? After we have reached this point, what we'll be doing is we'll be considering it. Okay, we'll be considering each of these. Okay, what do I mean by consideration? Listen carefully. We have 2 and 3 here. Sunny, 2 plus and 3 minus. Okay, 2 plus and 3 minus are here. Where is sunny? Sunny is present here. Now the positive values are 2 and negative values are 3. Okay, positive values are 2 and negative values are 3. Now for sunny I have no here. For sunny I have no here. Okay. And for the third sunny I got no. And for the fourth sunny I got here yes. And what happened is we are not getting all the values, or for see, for sunny I'm not getting all values as no, neither I'm getting all values as yes. I'm getting a mixture of no and yes for sunny. It has totally 5 values, among them 2 are no and 3 are yes, or reverse I told. 3 are no and 2 are yes, right? I'm getting in the reverse order or the mixture order. I'm getting it. I'm in search of something. Like if I tell it as sunny, always it should be yes or always it should be no. Like that value I'm considering. Okay, like that value not considering, I'm searching like that value. So let's see what is the next option I have. Here it became mixture. So we'll be writing question mark because it's a mixture. Let's see overcast. In overcast I have 4 yes and 0 no values. Let's have a look at outcast, how it's looking in the table. In the table, if you see where our outcast is there, it is present here. It is present in D7, D12 and D13. Now if you see the value here, what I got, yes. Here what I got, yes. Here what I got, yes. And here also I got yes, the 13th value, right. Here if you did not see carefully, all values I'm getting as yes. So when I tell someone that the weather is outcast, that time I will be able to see say that it is yes here. So here I got something to be noted. Whenever the weather is overcast, I'll be telling it as yes. So there I have no doubt. So I'll be just writing it as yes. I need not have any more classification there. I'll be just writing yes. Let's have a look at what's the story going on with the rain topic. In the rain, if I see where all rain is present in the table. In the table, if you observe carefully, the rain is first occurring in D4, then it's occurring in D5, then it's occurring in D6, and then it's occurring in D14. Can you tell me what the value here for rain? It is yes. Here also it is yes. Here it is no. I got a mixture here, so I am not concerned about what is present here. Here I got a mixture. I can just tell that I am not sure if it is raining. It can be yes as well as no. So what I'll be doing, I'll be writing here question mark. Now we have to consider sunny and rain. This is done. He got full marks. He got the promoted to next semester, and he is not concerned with the other subjects, right? But these both have backlogs. Okay, in some they failed, so we have to give more training to these two persons. Now let's consider sunny and rain. Okay, for sunny and rain, what we have to do, let's consider the first sunny. For sunny we have the following rows: d1, d2, d8, d9 and d11, I guess. So here why we are considering this is because the outlook thing is just separated here, right? Outlook is not separated, like it's taken out, it's considered and it is done, right? So we are not concerned with outlook, we are just concerned with temperature, humidity and wind. But in that, wherever sunny is present, okay, wherever sunny is present, we have to consider that rows, and that only we have to write, and we have to solve the further problem. So for sunny, I'll be just writing those rows which has sunny in it, and I'll not be writing outlook. Okay, I'll be just writing here temperature, humidity and wind. Here all these rows represent sunny's rows. Okay, so here I have some values, and then I'll be doing the same thing. What is the first column you can see here? The first column which you can see is temperature. What are the attribute values you can find here? The attribute value is hot and mild and cool. The attribute values will remain same even if it is not having cool here, just hot and mild only, but still you will be writing here cool, because you will be considering the whole data set and writing. Okay, so here we have the hot, mild and cool. The same thing for sunny you have to calculate. Now what we are considering first, that you have to observe carefully. In temperature, what we are means in which basis we have done this one. The whole table is for sunny only, right? We have made the shorter version of the bigger table, and that shorter version's basis is sunny only. So what we will be doing, this table is called as sunny table. Okay, so in that sunny table, how many 5 rows are there? 2 positive and 3 negative. The same goes here also, 2 positive and 3 negative. After we have written this one, we will be calculating the entropy with the same way as we have done before. And inside the temperature, we have 3 values: hot, mild and cool. We will be calculating the entropy for each of these. What the trick I told, that easily you can apply in 1 second you will get answer. 0 2 means 0, 1 1 means 1. If it is same means 1. If it is one of them is 0 means the final answer will be 0. Need not calculate, also you can directly write. Okay, don't worry, your marks will not be cut. Teacher also knows this trick. Okay, so after that you have you have got this one. You will be able to apply that in the gain formula. You have to substitute entropy of S and the summation of this. This is nothing but just like the probability of in the whole table how many times the particular thing has appeared, and out of how many possibilities. For example, the first one, if we consider here, it is 2 by 5. Okay, 2 is the number of times it has appeared, and 5 is the total number of instances. Which I am considering? I am considering for sunny. Okay, inside sunny there are 3 things: hot, mild and cool. For the hot, what I have written is 2 by 5. I have written 2 by 5. 5 is because totally 5 rows are there, and 2 I have written because hot is appearing 2 times. For mild also I will write 2. For cool, how many time I'll write? One only, because it's appeared just one time. Fine. After I've written this one, just calculate, you'll get an answer. This I have done for temperature. Same thing for what I have to do next, for humidity and for wind. Same thing, how many you have here, I have to note it down and apply the same procedures, and we'll be getting two more answers. Then what we'll be doing, we have another three racers. The racer's name is temperature, humidity and wind. Who is the fastest racer? The highest value, 97. So what we'll be doing, we'll be selecting humidity and then again classifying it. After you have selected humidity here, then we'll be seeing what are the possibilities in humidity, like how example we did for outlook. There were three values. For humidity, how many values are there? High and normal. After I've written high and normal, we'll be observing some things. If I consider high and if I consider normal, in high, what I have, just mark high here. For high I have no, no, no. Okay. For normal, what I have, yes, yes. Whenever there is normal, there is yes. Whenever there is high, there is no. So for sure I can tell, if someone tells me if the weather is the humidity is high in the weather given, I can tell the person will not play tennis. If the weather is sunny and the humidity is normal, I can for sure tell that the person will play tennis, because the yes values are given here. So that's what I'll be making conclusion here. In that conclusion, what I will have is, if it is high, that row's name I'll write, which rows have no there, and the normal I will write. For normal, obviously it is yes. So this thing is done. The Sunny has cleared his backlog. Okay, now rain has is left. We have to clear the rain's backlog as well. So here what we'll be doing, again the same procedure. I'll be briefly going through it. Now since there is in rain also there is three attributes, which is temperature, humidity and wind, we cannot just directly ignore it. We have to consider each of these. Okay, temperature, humidity and wind. See, don't get confused. First, like in the second iteration, I just remove the outlook value. Why I did that? Observe carefully the layers happening. In the first layer, when from outlook I came to the next layer, at that time I removed the outlook layer. But for humidity, when I came to this layer, I did not find any difference, so I got the final answer. If there was any difference here, at that time I will remove the row humidity, and again I will consider this one. But since there was no difference, I did not remove any row, and I just wrote the answer here. Now still we are in the same row only. This row is concerned with the removal of outlook. Here nothing will be removed again. You might get confused. Humidity is over, I should remove that one. No, see the level. Okay, don't be a fool, just see the level in which we are, you'll get to know the concepts. Okay, so keep this picture always in mind. We are in this level, we need not remove humidity. This parallel this like classmate. Okay, it's not a different layer, it's the same layer, so we'll not remove that. Okay, I hope so you got it. Now we'll be considering rain here. In rain also, how many attributes are there? Temp, humidity and wind. We'll be doing the same things here. Note down the values and calculate the entropy, find out the answer for temperature, humidity and wind, then make them again race, and let's see who wins it this time. In this time the highest value is this one, so who won is wind. So we'll be selecting wind here. Then we'll be seeing how many values the wind has. It has strong and weak value, so let's have a look at strong and weak. When we have a look at strong and weak, we'll be just marking where is weak, 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 and strong is here. I'll be circling it. So whenever there is weak, what I can say is yes, yes, yes is there, and whenever strong is there, there is no, no. So what I can tell, if it is weak, it will be he will play tennis. If the wind is weak, if the wind is strong, the person will not play tennis for sure, because there is no example in which strong has yes or weak has no. Both is not occurring. Wherever weak is there, as you can see, there is yes. Wherever strong is there, as you can see, there is no. So when we get that certainty, at that time what we can tell is, like, if the wind is strong, the person will not play. If the wind is weak, the person will play for sure. Okay, so this is your final answer, what you have to write here. It's a bit big in explaining, but if you just write it continuously and practice and listen to me for 3 more examples which I have considered from the previous question papers, you'll be getting the concepts in a crystal strong manner. Okay, so it will be easy for you to write an exam. Okay, so spend a few more minutes with me, you'll get to know the concepts very nicely. This is also the previous year question papers question. So here what we have given, same things. Instances is given instead of days. Here the numberings are given. Just don't care about the numberings. We are concerned with classification A1, A2. Okay, and classification is given as positive, positive, negative, positive, negative, negative. This is the target value. Okay, this is the target value which you have to keep in mind. In the previous one, the play tennis was target value, right? So here the in the question they will give, if you get confused, you might think like a2 might be target value because it's in the last column, but you have to read the question full. Okay, don't be in a hurry, you have to read the question full. That's an important thing. What is the entropy of this collection of training examples with respect to target function classification? If they give with respect to classification, that means this is the deciding factor. Like in the previous case there was play tennis deciding factor, right? Because they had given in the question. Now they have given classification is the deciding factor, so I have to consider classification only. Fine. So when we consider this one, again the same things we'll be doing. Now recall what I told in the last time. First you have to see how many columns are there. In our case there are just two columns which are of relevance to us. So we'll be considering this column first, then we'll be considering these columns as it's given in the left right order. Okay. So when you consider a1, at that time how many values we have for a1? We have t and f. There are two values for a1, right? So we'll be first calculating the entropy of a1, then I'll be calculating entropy of a1's true, a1's false, and I'll be choosing the winner. Okay, you're getting what I'm telling, right? See here, they'll be asking you to find the information gain of a1 a2. So whatever they have given here, whatever I'm telling, that only they have asked here. Okay, first consider attribute a1, then consider how many values a1 has, true and false, right? Attribute a1 has how many values, true and false, they're distinct values. So what I told, first you have to calculate for s, 3 and 3. 3 and 3 means there are three positive values, 1 2 3, and three negative values, minus minus minus. Okay, that is s. S means the whole data set. And for a1 how many values are there? For a1 if I'm considering just true, in that I have two positive and one negative value. Listen carefully, I'm considering each value now. Okay, so if you get confused here, I have a look at here. This is a total table. After you have considered total table, you have to consider each attribute, and inside attribute we will be considering each value. Attribute is a1, the value is t, so a1t. A1t is written as this one. In A1t, how many positive values and how many negative values are there? In A1t, how many positive values are there and how many negative values are there? In A1t, I have three values, which is two positive and one negative. That's all what I have writing here, two positive and one negative. Substitute these values and find out the answer. Same thing you do for false also. How many values are there for A1 false? One positive and two negative. Okay, one positive is there and two negative is there for a1. A1's false. That's all you will be writing here also, sf, and you will be inserting these values. Calculate this one and find out this answer. That also you'll be getting here, and this answer you keep in your mind. Okay, then you have to consider which attribute. The second column will consider a2. When you consider a2, at that time also you'll be getting some similar values. Those values you have to substitute and find out the answer for gain. After you have written that one, note down both the gains and let's see who fails and who passes. If you write those two values together, what you will be observing is s of a1 will have 0.0817, a slightly more value than s of a2, which is 0.0. Okay, so small time also matters. Even if you miss 1 second, the train will go, right? You will not be able to catch the train. So very small things also matter. So here you have the maximum gain, and we'll be selecting which one. A1 will be selecting. Okay, after I have selected a1, what all attributes it has, true and false. Now we'll be noting down the rows in which true is appearing, we'll be noting down the rows in which false is appearing. Let's see a1's true and false. In a1's true and false, if you observe carefully, here we have true 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 and we have false false false. This is a1's true and false. Here we have positive positive and negative. Here we have positive negative and negative. Okay, so since it's not same, what I mean is, if I'm just considering true here, okay, I should get all positive here or all negative here. Then I'm for sure that whenever it is a1 and true, I'm getting positive or I'm getting negative. But here what I have, mixture. Same goes for false also. Here what I have, mixture. So if it is mixture, I should consider what, next column. Even whenever it is a mixture, I have to consider what, the next column. If I consider next column, then I'll be writing here a2. Okay, same thing I'll be doing here also. I'll be just writing a2, and again I'll be seeing in a2 what's happening. Like for example, in attribute a2 I have these values t and f, and I'll be going level deep into it. In a2 how many values are there, true and false. Let's have a look at a2's true and false. In a2's true and false, there is true true and true true. Here have a look, positive positive negative negative. In false also I have positive and negative. What it means, it's a mixture. okay, but the mixture is equal. Like for example, two positive are there, two negative are there. In false also, one positive, one negative is there. Okay, so what I can conclude from that is, if I write here, if a1 is true and a2 is true, okay, a1 is true and a2 is true, both I'm considering, at that time you'll just get rows 1 and 2 which is positive. If I consider a2 as a1 as true and a2 as false, then only 3 row is there which is negative. Okay, so what I mean is, you know, you'll observe carefully, a1 true 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 I wrote here, okay, and a2 is true true, okay, and here another is there. If you see where both true are occurring, in this place both true are occurring, do they have a mixture here? No, obviously it doesn't have a mixture. If both are true in this case I can certainly tell that the classification is positive. If someone asks me a1 a2 both are true, in that case what do you tell about the classification? Even if the person does not specify which instance he is talking about, I can easily tell it is positive. Why? Because whatever instance he is talking about, I don't care about him. It is positive in both cases. I'll tell the answer is positive. Fine. The same goes for false also. In false, if both are false here, which row it is? The false row is this one. In that case there is a positive value here, right? So in that case what I can tell is, if a1 and a2 both are positive here, means both are false, at that time the value is positive here. Okay, so that's what it's mentioned here. If it is false and a2 is also false, 4 is there which has a positive value. The same thing can go for this one, which is true false and false true. Let me explain you what is that. True and false, where it is true, where it is false. Okay, so a1 should be true and a2 should be false. True false, true false, only one value is there which is negative. So if someone tells me a1 is positive, a1 is true and a2 is false, at that time we have a negative classification. That's what I'll be telling. If they ask me in the reverse way, false true, false true, these two rows match, and in these two rows also it is negative, so I can tell them it is negative. Whether it is true false or false true, both are having negative values only. So that's what I've written here, both are having negative only. Okay, negative and negative in this case and this case also. Now looking at this example, this might slightly confuse you, okay, but let me tell you, this same thing is happening in the previous one also. In the previous one we just had three things, here we have two things. Let me explain you. See here, when it was outlook, okay, I'll show you the previous example also, but see here, this was outlook here and it was sunny here. If you observe the previous example, if you remember, it was overcast here, it was raining here. Here we have humidity. Okay, so what happened is, sunny won the race between these three. Here a1 won the race between a1 and a2. Okay, outlook had other things like outlook, temperature, humidity and all. Inside that, outlook won. So in our case, a1 a2 was there, a1 won. Okay, and it has the attributes true and false. Okay, so true values are there. In that true there is a mixture, just like how sunny has a mixture, right? When sunny has a mixture, I was considering the next attribute, right? Next attribute of outlook's teammates are outlook, temperature, humidity and wind, right? These four are the teammates. So whenever I had a mixture in one of its attributes, listen to me carefully, when outlook had the mixture in one of its attributes, I was considering its teammate, right? So here also I'll be doing the same thing. Whenever a1's attribute has a mixture, I'll be considering the teammate of a. Which is the teammate of a? The teammate of a is one and the only one, which is a2. So I'll be writing here a2 just as how I wrote humidity. After I had written humidity, I had again classified it as true and not true and false. Two values were there, right? Humidity's values were high and normal, I guess. Yeah, high and normal I wrote. In the same way, a2's attribute I will write, which is true and false. After I had written humidity is high and normal, I considered that and saw in the table, whenever it was high it was positive, whenever it was normal it was negative. I don't know about this one's sure values, but it was same values, right? Whenever it was this one, the same values were there for all the instances. Whenever it was this one, all the instances had this same value. So here also it's the same thing. Whenever it is true, all the positive values, whenever it is false, all the negative values. Okay, the same, this also is repeated, mirrored here only. So this also is mirrored here only. With the same analogy I can tell, and I hope so you got the concept behind this question. Okay, So let's discuss two more questions regarding the same thing to make a concept more clear. So make the decision tree using ID3 for the given table. Here the table is given and here three values are given, A1, A2 and A3. Okay. Now tell me what is the first thing you will do. The first thing what you will be doing in this question is that you will be seeing how many instances are there. Okay. 10 instances are there. This is the first thing you will be seeing. Okay. Next thing what you'll be seeing is how many attributes are there, A1, A2 and A3, and which is the classification attribute. By the name itself it's given, this is the classification attribute, this will be considering at the end. Here A1, A2, A3 are there, these are my training examples. I mean training examples column name. Okay. Now what I'll be doing is I'll be checking out first A1. Then I'll check out A2, then I'll check out A3. Whenever I'm considering A1, first I have to see how many distinct values are there. True and false. These two are the distinct values. So for each true and false, I'll calculate entropy. Then I'll calculate entropy for whole A1 and I'll calculate these three values, and there is a formula, gain formula. I'll be applying these three values in this formula and calculating one answer. Same thing I'll do for this one also. I'll calculate one answer. Same thing I'll do for this one also. I'll calculate one answer. In these three answers, which is the best one, I'll be choosing, and then I'll be making the decision tree based on that. Suppose that A2 got chosen. So when I have chosen A2, next what is my step? Next my step is, in A2 how many places hot is there, that I'll take it separately. Okay, how many places hot is there, I'll take it separately. But before that I'll be checking if hot is having mixture or not. If it is having mixture, then only I will consider it further. If it does not have a mixture, for example hot is no, no, here also no, and wherever hot is there all has no only, so obviously I can just directly write the first thing A2 I'll write. If it is hot, I can just directly write here no, right? Just like how I wrote for overcast. Outlook was here, overcast, yes, right? So this page number 17, let's remember that. I am showing you what I am trying to tell here. What we wrote, we directly wrote here yes, right? Because for all these instances of overcast I had the value yes. In the same way, it was page number 17, right? Okay, in the same way, if for all the humidity or the hot values, if I have no, I'll be just directly writing A2 here, and I'll write hot, I'll be writing here no. But here we have a mixture, so I cannot write no here. I'll be further classifying hot based on other two values. What are the other two values? I'll be considering which row? I'll be considering A3, right? Because A1 is over. I mean A1 is not over. We can consider A1 also and A3 also, both we can consider. Okay, how will be that consideration, on basis of what we'll be considering A1 or A2? We'll be learning it later, but we will choose either of this one, and when we have choose this one, the separation will be made based on that. For example, if I choose based on A1, hot has true values, true and false, then I'll be again seeing true has all the no values or false has all the same values. If it is there, I'll be writing that as such. If it is not, I'll be again writing question mark and ending the problem. Not ending the problem, again I have the third row, right? I can consider this one. If it is true and high, all places it is no. If it is true and normal, all the places it is no, that I'll see. If it is yes, all the places it is no. For normal it is no, like that I will be writing. Okay, so this is what I'll be doing. Let's go through it. Okay, same thing as previous one. First you have to see the attribute A1, write down the values for A1. You have true and false. Calculate the S value, which is the entropy value for A1. After you have done this one, calculate S true, S false. Two things, two values for A, you will calculate two entropies. After you have done that, substitute in this formula and keep it as such. Same thing do for A2 also and A3 also. Then you will be getting three answers. Choose the maximum answer, that will be your winner. After I have got that one, in this case I got A1 as the winner, so I'll be writing here A1. After I have written A1, true and false I'll be seeing. Okay, let's have a look at true and false of A1. In A1, how many true are there? Here true is there, true, true. I have no, no. True is there, no. True is there, no. True is there, yes. I'm not concerned anymore. Here I got true, yes. Here it is true, no. Means there is a mixture. Whenever there is a mixture, I have to classify it further, right? I have to classify that as further. If this is having a mixture, obviously this also has a mixture. I'm not sure. Let's see. False is there. False, yes. False, yes. And false, yes. False, yes. Okay, so since false has no like mixture, we'll be just writing yes. Okay, sorry, I told it in a wrong way, like if true has mixture, false will also have mixture. No, you have to check it. Okay, so here since we got yes, we'll not consider this one further. We are just concerned with separating and making certain this structure mixture. Why we are making certain mixture is because I want certain answers like yes or no values, even if it causes me to separate it further. Okay, so here what I'll be doing, I'll be just again classifying and choosing yes or no. Fine. So what I'm concerned with, a1 is done. When a1 is done, I'm coming to the next level. In next level, what attribute I have, those only I'll consider. a1 I'll remove. If I remove a1 and I consider just true values, at that time what rows I have, these are all true values. For a1, wherever I had true, that values are written here. Okay, so what I mean is, wherever I had true here, that rows are only written here. Here I had true, true, true. Sorry, not that is not true. True, true, true. So these five values I considered the separate rows and I've written it together because we are just concerned with that one, right? So after I have written that one, then again the second classification will be made based on a2 and a3. a2 will be taken and inside that these classifications will be made, and I'll be writing answer here. I'll be getting the answers and substituting this in this formula, and I'll be getting my answer. Fine, like that we'll do for what, a3 also, right? a2 and a3 both it has to be done. After I've done that, I'll get two answers. I'll make them race in between them. I'll find out which is the better answer, and that I'll be selecting. After I select the better answer, in this case it is a3, so I'll be writing in this place a3. a3 has how many values that I'll be seeing. In a3 I have two values, which is high and normal. Now consider high no, high no, high no, and normal yes. So I can directly tell whenever it is high it is no, whenever it is normal it is yes. Directly I'll write the further classification. Whenever it is high it is no, whenever it is normal it is yes. Then since this one was done, I am not concerned. Here I got discrete values, no, yes, yes. The answer is this much only. Okay, so this was one of the question paper questions. So make sure you practice this one by writing. By listening nothing will happen. You have to write and practice. Okay, this is the question paper question for the slightly different topic, which is for Boolean functions. Okay, to draw a decision tree and these Boolean functions will be given, how you will do that. Observe carefully what is the first question, A and not B. Okay, so for this, if you get this question, what you will do is, first letter which you have, see that A, isn't it? So you'll be writing here A, and then you will be having here as not B. Now tell me one thing, if I tell you that this statement is true, okay, this truth value is true, if this truth value is true, this has to be true and this has to be true. If this is to be true, A is true, and if this is to be true, B is false. Then only if not or false will become true, right? And this is AND condition, both should be true for sure. So that's what I'll be writing here. If it is A and it is true and false, two values it can have. If it is false, then the final value will be no. If it is true and B is also true, at that time only sorry, B is false because not B is given, right? If A is true and B is false, then only I will have yes. If B is true, I'll have no. Okay, I'll show you why B true. It's not just now I told. If B is true, then this will become false. The whole will become false, and of anything false is nothing but false only. So I am getting a false value at the end when I took B as true. So I'll be writing there no. Okay, like that only. In the next question, A or B and C. A or B, anything can be true. Suppose that I tell you this whole statement is true. If I am given that A is true, do I need to check this one? No, I'm not considering this one. A is true, the whole value is true because it's OR. I'm independent of this one. So if A is true, I need not check this one. But in case if A is false, then I'm totally relying on this one. If it is true, then the whole value will be true. If it is false, the whole value will be false. So that's what I'll be writing here in B. First, I'll be considering A. If it is true, means the whole thing will be true, right? If it is true, means the whole thing will become true. I'm not need not consider this one. So whenever it is true, I'll be just directly declaring the whole value is yes. If A is false, I'm completely relying on B. If B is false, then it will become no. If it is true, still I'm completely relying on C. If C is no, false, it is no. If C is true, it is yes. The only condition where it can be yes is you have both B and C as true. Then only it will be yes. Other all rest case it will be no. Okay. Moving on, you have the next question, which is A XOR B. XOR means what? If it is plus and minus, then it will be plus. If it is minus or plus, then it will be plus. Okay, if both are minus or both are plus, it will be minus and minus only. Okay, why? Because exclusive or means it is actual or. Both are or means both are positive means it is not exclusive. Exclusive means only one should be positive. If one is positive, the final value is yes. In that way, we'll make a graph. Let's make it together only. A is given. First, what's your step? You'll be writing here A. XOR is given. Okay, A can have true and false values. Now A can have true and false values. Now it depends on B. In both cases, it depends on B. I cannot tell if A is true, the final answer will be true. What if A is true and B is also true? There is a possibility that it will be no. Both could not be true. If it is true and false, then only I can tell it is yes. If it is C here, it can be true, it can be false. False, false, it will not be true. False, true, it will be true. I mean yes. Like that we'll be writing A XOR B. This is the graph. If I show you what I have written, this is the same thing which I have written. Okay, same thing you will be doing for this one also. Or is present means if this is true means I am not concerned with this one. So you have to consider first this one. A and B is given. A can have two values, true and false. B is given. If A is true and B is also true, then only it will be yes. If B is false, then it will be again I have to consider this one. Right, I cannot tell the whole equation is false. Why? Because what if this become true after this one? B is false, but this whole is true. Like for example, then I'll consider C. C will have two values, true and false. Okay, suppose that C is true, and then I have D. D have two values, true and false. In this also D is true, so I got the reach here. Right. So by this path only I got to reach where the equation is true. Right. So here I cannot declare it as false always. There is a possibility existing through this path which makes me which makes the answer true here. So I should not write false here. I should explore that node. So A is false. What if A is false? This whole thing will become false. Okay, in this case I'm talking if A is false, this whole thing will become false. I'm totally reliant on this one, C and D. So again I'll ask C if it has got or not. If it has not got, the game over. If it has got, there is a chance I'll consider D. If D has got, there's a means that we have got the answer. True means this true, the whole thing will be true. Else if D became false, at that time you will not get anything. D became false means what? See, if D became false means this whole thing will be false. Or already this was false. False or false is nothing but false only. Okay, so I hope so you got the answer. There's a brief like this image you can go through. You can note it down, take screenshot or something. So here the final answer is present. Whatever I explained, the same thing is present here also. Okay. So this was the question paper questions. Now the 2/3 of this part is done. We are just remaining with some theory questions. We'll be discussing in depth now. Okay, not in depth, like briefly we'll be discussing and how do you remember the points, etc. Okay, so let's see the algorithm. So what all you need to remember in the algorithm, I told you like after the explanation will be coming to the algorithm. So let's see what is there in the algorithm. So you have to first write the basic algorithm. ID3 is ID3 will have example, target, attribute and attributes. Examples are the row values which you consider. Target attribute is the final column value classification, yes or no. Attributes are the middle values, whatever is present in the columns. Okay, that is known as attributes. So that's what the same thing is mentioned here, and the actual algorithm starts from here. Create a root node for the tree. If all the examples are positive, return the single node tree with the label plus. If all the examples are negative, return the single node tree with the label minus. After you have done this one, if attribute is empty, return the specific single node root. If the attributes is empty, there are no attributes only, return the same node with the label that is most common value of the target attribute in example. Most common value means, see, let's take an example here only. If I have this one, okay, suppose that if I have yes here also, okay, for both thing I am getting yes, and this is an empty attribute. So what I will write is sunny. Directly I will write yes. It does not matter if it is high, normal or something humidity. Directly if it is sunny, I will write yes, like that. Okay, if there is any empty value, I'll just write the most common value which is occurring in the examples. Next, otherwise if these all are not true, then I suppose that it is the first time, like for example if there is a yes and no mixture, something like that. So in that case what I have to do is I have to do these things like from scratch. I have to do the attribute from the attributes is best star classifies the example. Best star means choosing a best attribute. Okay, and the decision is made for the root. For each positive value, add a new branch. Okay, for each possible value of a, then add a new branch corresponding to the test a. A is equal to vi. You have to just keep on adding new branches and let the examples be the subset of examples that have value vi for a. You are making a subset, like for example, you have got many seeds. Okay, from that seed you just want to put two kinds of plants, mango and apple. You'll take those two seeds only. So adding a new branch is nothing but taking seeds. Which seeds you are taking? The subset of this whole one. From this whole you are taking a subset. Okay, so that's what you will be taking. And for each example, what you have to do is, for the new branch, add a leaf node with the label most common value. For that, each node you will be adding the most common value, and then else you will be adding a new branch and add the subtree. Either add the node and the new branch, or add the whole college and the new branch. Okay, then you can use ID3 algorithm to solve the problem. After that, finally we'll be returning the root. Okay, just somehow you memorize this one. This didn't make sense to me also, but the example made sense. That's more than sufficient. By seeing the example only we can write this in our own words. Okay, so that's what about the algorithm. And entropy and information gain, by now you have understood what is entropy. We'll be calculating positive probability and negative probability. And like an example is also given here. If it is 9 and 5, it will be 9 by 14 and 9 by 14 here, and we'll just find out the answer here. Information gain, just substitute the value of s and a in this equation and you'll be getting the answer. So here's an example given, simple example. Here we have s as 9 and 5. S has two attributes, weak and strong, 6 2 and 3 3. Now in entropy you will be writing this one. Entropy of s is nothing but this one. We see there is a formula up there, right? You can see that and find out the entropy of s. Same way you have to do the summation part also. Entropy of s weak and s strong, and that also will find out the answer, substitute and get the final answer, which is 0.048. Okay, so this is what the theory part is there. And finally also we have some theory part. For example, like the issues are there. Okay, there will be some question. They will be asked to write the issues in the tree representation, decision tree. So we'll be discussing that. Before discussing the issues, you need to understand what is overfitting. Overfitting, you already know what is overfitting means. The training data is there, testing data is there. For the training data, it performs very well. If it is given in training, it will perform very poorly. That is overfitting. Okay, so there's a definition given here. So if you want, you can skip. Otherwise, I can explain this what it's written here. See, there is a hypothesis space. Okay, H. Inside that H, there are many small H. Okay, so hypothesis small h is set to overfit the training data. That small h, okay, that small h, one small h is there, it is overfitting the data. When we can tell, we can tell when there exists some alternative hypothesis h dash, another small h is there which is h dash. Okay, such that h has a smaller error over h dash in training examples. This is performing well in training, but h dash has smaller error than h over the entire distribution of instances. Means testing, when there is a testing time, it will score more. Okay, if there exists h dash, then h is overfitting. This is overfitting. In training it will do good, better than this one, but overall when it comes it will not do good. That is called as overfitting. We can overcome by doing two steps, which is stop going the tree when it is time to, when it is perfectly classifying, but it is very hard to actually know when it starts perfectly classifying. For that we go to the second technique. Here it is given to avoid overfitting of the data, we will be using two methods: reduced error parsing, error pruning, and rule post pruning. Pruning means removing the errors. Okay, so reduced error pruning, in this example, what you have to do is you have to replace subtree with the most common classification. If it is yes here, what I will just do is humidity I'll remove, I'll just write sunny yes, like that. Okay, you have to do for both of these. Okay, it could be replaced with yes or no. Okay, if it did not have mixture, obviously I would have done now only how it the replacement happens, but it has mixture of both, right? So I can't do that. Okay, that's what is called reduced error method, and we'll be applying each of these after replacement, checking which acts more better, and based on that we'll be making decisions. Next, the technique is rule post pruning. Okay, rule post pruning. In this, what we have is mark the rules. Firstly, we will be making rules out of it. Outlook is written as sunny and humidity. If both are true, at that time it is high. High and no. Okay, sunny humidity, if it is high, no. Sunny humidity, if it is normal, yes. Overcast, it is yes. Rain wind, it can be both no and yes. Rain wind, strong no. Rain wind, weak yes, like that. Okay, rain wind, strong no. Rain wind, weak yes. Okay, then we have the outlook and the humidity thing. Sunny no, and high no, so we cannot consider it as equal. Here also you have to make some changes. Okay, check whether which gives more accuracy. Splitted rule. Okay, so which gives more accuracy, we have to check that. Okay, so that kind of rule is called rule post pruning, and it's better than reduced error method in the large scale. Another important question, which is how to handle continuous values. See, the values are given. Which values are there? Temperature 40, 48, 60, 72, 80, 90. Plate N is also given. As you can observe carefully, no, yes, this is the group of no, group of yes, again a no. So there is a sudden change. Here also there is a sudden change, right? So what we do in that case is 40 plus 60 by 2, which is 54, it will lie somewhere here. 80 plus 90 by 2 is 85, it will lie somewhere here. Okay, when it has lied here and here, at that time what we will be doing is we will be calculating the gain of candidate thresholds. Okay, for temperature greater than and less than 54. Then we will be doing the same for 85 also. Whenever we get new answers, we will be exploring them in depth. First we will do for 54, then for 85. How you should do that is, first is greater than and second is less than. So here total is 3 and 3. Okay, for the outlook, not outlook, information gain, for which we are considering this one. Okay, for the whole, yes, 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 and no, no. Okay, 3 no's are there, 3 yes are there. That answer is written here, the whole table itself. Okay, that entropy is written. For less than 54, there is no yes but 2 no's. There is no yes but 2 no's. Less than 54. Okay, there is no yes, as you can find here, but 2 no's are there. So that one will be writing for less than 54, and greater than 54, the same thing will be writing, just that this thing should be substituted in the final answer. And gain as temperature greater than 54, here we will be writing 1 minus, and these values are nothing but 2 by 6 into 0.0 minus 4 by 6, 0.8112 is equal to 0.459. Okay, 0.459. So this is what answer we will be getting for gain as temperature when it is greater than 54. Okay, for 54 we got one answer. Same thing we'll be doing for what? We'll be doing for this one, 85. When you do the same thing for 85, you will get another answer here, which is 1908. So we'll be selecting the first one, which is more better, and that's how you handle the classification values. Then the super important question, explain some of the issues in decision tree learning. Issues in decision tree learning. Suppose that there is a roller coaster, and in that roller coaster you go above a tree. Okay, very weird roller coaster. In that roller coaster there is a tree, and above that tree you will be going like this and all. So you did not like this roller coaster at all. There was many issues like that. You have to remember. Okay, issues in decision tree learning. The first thing you have to remember is there is a roller coaster in which you ride it upon the tree, and it was very bad experience. There were many issues. The first issue is the overfitting of data. Wherever tree was there, for each leaf it was there is a road built on top of it. Okay, that was overfitting the data, and it was continuous. You did not get the break in between. Continuous data. Okay, continuous valued attributes. Then handling training example with missing attributes, and in between what happened, you were moving up and down. Some of the holes were there inside that you went and came back again. Okay, and since there was a hole, you wanted to replace it. Okay, but you ask someone how much will it cost to replace, they tell different costs. Okay, it was very costly to replace. Okay, so what you did is you thought of any other way in which I can do, that is nothing but alternative measure for selecting attribute values. Okay, so those were some of the issues. If I just talk normally, overfitting the data means the data what is considered that is just performing well in training data rather than testing data. Incorporating continuous value attributes, like for example how I showed you up, right? Continuous values. Handling training example with missing attribute, you know better than me. Handling attribute with different costs. If there is different cost, it will be hard to keep track of what cost which attribute has. Alternative measure for selecting attributes. Obviously if one has some disadvantages, to overcome that some other algorithm should be means explored and found out, right? So we can apply it in different cases. So that's what is written here, alternative measures for selecting attributes. So those were some of the issues for the decision tree learning. Then we have hypothesis space search in decision tree learning. Hypothesis space search is, it's just a space search where all the possible combination and the answers are there. From that we are selecting the best one. For that ID3 can be used, and this theorem not explaining, I'm just telling you the basics of it. there's a tree here and many possibilities of selecting in this one and so on based on the information gain values. Okay, just doing that one. And some of the limitations of ID3 are it's a complete space, it will check all the possible combinations, and it maintains only current single current hypothesis. There is no backtracking, and all the training examples are used at each step. Okay, the reason why I'm not explaining is because it's not important one. Okay, it's just normal question for your understanding, so you can go through it whenever you want. Explain inductive bias, and this is the previous year question, but still it's not repeated, so I don't make it super important one. ID3 and kind elimination method with inductive bias, you have to differ it and tell me what is the differences. Okay, so inductive bias is a set of assumptions that together with the training data deductively justify the classifications assigned by the learner to the future instances. It just adds some information to whatever the search we are doing so that better search will happen. That's all. ID3, some of the features are select shorter trees and select the trees which place the attributes with the highest information closest to the node. Okay, it searches complete space, and ID3 searches complete space, and it searches incompletely through the space from the simple to complex hypothesis. Okay, sometimes it searches completely, sometimes it searches uncompletely. Okay. Next, we have candidate elimination method. In this, the version spaces all the candidates combinations are present, and it searches in that space complexity. And inductive bias is solely a consequence of the expressive power of hypothesis representation. Then you have two types of biases, which is preference bias and restriction bias. Okay, so preference bias, based on the preferences you will be making the decisions. Restriction bias, restriction bias. In restriction bias, there will be a kind of restriction based on what choices you can make, which is categorical restriction on set of hypotheses is considered. Okay, that was about the what was the question? Inductive bias and contrasting it with ID3 and candidate elimination. Occam's razor is also given. You can remember this point if it is asked somewhere. Prefer the simplest hypothesis that fits the data. So that's all. Make sure you hit the like button, subscribe to my channel for more videos like this, and your support helps me make more videos like this. And I'll upload the next part in the next video. And thank you so much for watching. I'll see you in the next one.